Welcome to E-Padasala lecture series in computer science. In this module, we are going to discuss about greedy algorithms. This is a design paradigm using which we can solve many optimization problems. In this module, we are going to discuss the fundamentals of this design paradigm called greedy approach. The learning objectives of this particular module are to explain the fundamentals of greedy algorithms. We want to explain some problems as an illustration of this design strategy. We will discuss a problem called the coin change problem. Then we will discuss about scheduling problem, which are one of the most important problem in computer science domain. So, greedy algorithms are used to solve optimization problems. What is an optimization problem? An optimization problem is a problem that will have certain objective function. The objective function is normally about the maximization or minimization of a certain criteria. Then we will have feasible constraints. These constraints are stated as a function, and any solution is supposed to satisfy these feasibility criteria, and an extremum requirement like the maximization or minimization of the given objective function. What is the aim of the solution of an optimization problem? Any problem will have n number of solutions. All the solutions are called candidate solutions. All the solutions that satisfy the feasibility criteria and achieve the desired extremum is what we are calling as optimal solutions. In other words, a problem may have many candidate solutions. Out of that, some solutions are the best solutions that satisfy not only the feasibility criteria, but also the objective function maxima or minimization. These sort of solutions are called optimal solutions, and the aim of computer science is to design solutions that are considered to be the optimal solutions. Many design paradigms are available for solving optimization problems. Some of the design paradigms are greedy approach, dynamic programming, etc., etc. We are going to discuss about that sort of greedy approach only. Greedy approach works well for certain situations. Many times it is able to generate an optimal solution for the given problem, but at the same time there is no guarantee provided by the greedy approach for the optimal solutions. In other words, there are certain situations where the greedy approach may fail also, but nevertheless it is useful to review this design paradigm, because in many cases it gives optimal solutions or at least near optimal solutions. Near optimal solution means the solutions are not optimal, but nevertheless can be considered more or less equivalent to an optimal solutions. That is the reason why greedy algorithms are still studied as part of the design paradigms. In our daily life, we encounter many optimization problems. These are some of the examples of problems that normally we do in our daily day-to-day routines. Making coin change. For example, if somebody is asking for coin, we are looking for the minimum number of denomination to satisfy this requirement. Finding the shortest path. For example, I want to go to my friend's house. I may be interested in knowing the shortest path from my house location to his house locations. Storing files in the compressed form in a disk or hard drive. Optimal loading of suitcase, where the space requirement of the suitcase is well defined. So, I have to look for maximization of the items utilizing the space very well. Similarly, the optimal arrangement of books in a bookshelf. If you see all these problems, you can see the common criteria. All these problems are optimization problems. You can see that the objective function is always something to maximize or something to minimize. For example, in the case of profit, it may be the maximization. If it is a case of effort or path, it will be some sort of a minimizations. You can also observe that all these problems have a hidden or explicit objective function, certain feasibility criteria, certain extremum requirement, and under all circumstances what we are interested is some sort of an optimal solutions. So, these are the components of the greedy algorithm. So, for solving this optimization, I have to write algorithms as part of the greedy approach. So, you can see that the components of the greedy algorithms are objective function, which is given by the given problem, then generation of multiple candidate solutions. So, out of that I have to pick up the solution, that means some sort of a selection procedure is required, and once I select a solution, or in other words making a particular choice, then I have to check whether it is feasible or not. It is called the feasibility check, and once I know that a solution satisfies a solution, then I can add that as part of my solutions. I will keep on adding the solutions, and finally, I will check whether the solution of the given problem is obtained or not. If it is obtained, I am going to return the solution back as the solution of the given problem. You can see the algorithm, formal algorithm of the structure of a greedy. This is the common template using which most of the problems are solved. So, you can see that initially the solution set is null. So, we are starting a loop while the solution is not complete, then we are selecting the best candidate solution x, and I have to check whether it is feasible. If x is a feasible solution, then I am adding that solution of x to the solution set. Now, this goes in a loop, then finally, I am checking whether solution is obtained. If solution is obtained, then I am going to return the solution set. So, you can see that this is the kind of template which all the greedy algorithm must follow. So, you have a selection procedure for selecting the candidate solutions, then a feasibility check to check whether the selected solution is feasible or not, and finally, the solution check. Solution check checks whether the solution has been obtained or not. So, you can see the characteristic of this particular algorithm. So, there may be multiple choices. So, all the choices form a sequence of choices. So, that means, I have to take a decision at the various stages. Then each choice should be the best choice. This is how the name of the greedy approach is evolved. Like a greedy man, what we are trying to do is, given a solution choices, we are going for the maximum choice that benefits me. In other words, we are going for some sort of a greedy choice which looks good as of now. So, instead of bothering about any other considerations. So, once I make the choice, then the problem is reduced. So, by continuing like this, we are able to solve the given problem. So, the essential characteristics are multiple choices, sequence of choices, and the local optimality, and the usage of the choice reduces the instance or some of the salient features of any greedy approach. So, in other words, the greedy algorithm should satisfy these two properties, greedy choice property and the optimal substructures. So, greedy choice is always part of a certain optimal solution, is what the greedy choice property is all about. In other words, the global optimum solution is obtained by combining lots of locally decisions that are taken by the algorithms, and finally, it has to satisfy a thing called optimal substructure. That means, the problem that is constructed for the global problem is also optimal with regard to the sub problems that are contained within. Fine. So, we have seen the theoretical concept. So, let me recap. You have objective function. So, you have certain feasibility criteria. So, now we are going for selection, then checking feasibility, then adding that to the solution. So, now we will try to apply this for the coin change problem. All of us encounter the coin change problem in our day to day life. Let us assume that one of my friend is asking me 273 rupees. So, imagine like this, how I am going to fulfill his request. I will not give 273 1 rupee coins, because in that case I require 273 coins. So, which is not an optimal solution. So, the coin change problem is something like this. We want to minimize the number of denominations. So, we are given number of many denominations, and the problem is to minimize the number of denominations. Once we have a problem which is stated like minimization, then immediately we can recognize that this is going to be an optimization problem. So, the optimization problem has got an objective function, that is to minimize the number of coins. Then What are the candidate solutions? Fine, I can solve this problem using multiple combinations. I can give 273 1 rupee coins. This is one solution. Like that, I can solve that request by means of multiple ways. Every way constitute one candidate solution. So, in the greedy algorithm, I have to go for a selection procedure. So, I have to look for the largest denomination. This is what the selection procedure is all about. Then I have to check whether it is feasible or not. So, that represents the feasibility check, and once a coin satisfies, then I have to keep on adding that into the solution set, and finally, I will check whether the solution is obtained or not. If the solution, that is the required amount, is collected, then I am going to send that as the solution set, otherwise I will keep on adding the coins. So, assume that we have denominations. Let us avoid the units like rupees, coins and all. Let us assume that some sort of a scenario where the denominations are 100, 50, 20, 1. We can add any units. So, assume that these are all coins for simplicity sake. So, a friend is what you say expecting 273. So, that means I have to satisfy that. So, one of the way of solving this problem is I can give 273 one denomination coin, which is clearly a suboptimal. So, what is the greedy approach? Greedy approach looks for the largest denomination. The largest denomination is 100. So, therefore, the best way is I can give 100. So, now the total amount is reduced as 173 minus 100, that is 173. I am giving another 100. So, that means it becomes 73. So, I am looking for the next largest denomination that fulfills the request. It is going to be 50. So, 50. So, then it becomes 23. So, that means largest denomination is 20. So, 3 is pending. So, which must be satisfied as 1 comma 1 comma 1. So, the coin change problem for the expected 273 will be 100 plus 100 plus 50 plus 20 and 3 ones. So, this is the what is a optimal solutions. US money always guarantees the solution, optimal solution, and in some currencies it is not possible. There are certain cases where the solution produced will be suboptimal also. For example, assume that we have a denomination of 40, 25, 22 and 1. Let us assume that the expected money is 50. So, what the greedy algorithm will do? It will look for the largest denomination. So, 40 is the largest denomination. So, 40 will be given. So, that means 50 minus 40 is 10. For 10 the largest denomination is 2. So, that means it becomes 2 comma 2 comma 2 comma 2 comma 2. So, that means you can see that there are 6 coins that are used to fulfill the request of 50. But we know very well that this is not optimal solution, because we can give 2 25 pies 225 denomination as the optimal solutions. In other words, greedy algorithm is not always optimal. So, we can put everything into a informal algorithm. So, initially the solution is null. So, for the given request, grab the largest denomination. This is going to be your selection procedure. If feasible, then add the coin, otherwise reject it. It is the feasibility check. Repeat till the collected change equals a requested amount or not. This is going to be what you say the solution check. Finally, I am going to return the solution set. This is the informal greedy algorithm for coin change problem. So, this is the algorithm now. So, you can see that we are initializing solution equal to 0, sum equal to 0, because no coin is dispersed. When sum is less than r, where r is nothing but the requested amount, I am grabbing the largest coin. So, when the sum of the largest coin plus x is less than or equal to r, then we are adding the coin into the solution, then we are incrementing the sum. So, this goes in a loop, and when we come out of the loop, the solution set will have all the coins that I am going to return. So, what is the complexity analysis? Complexity analysis of this algorithm is that algorithm uses only the arithmetic operations, which takes only the constant time. So, therefore, the complexity analysis of this algorithm is order of 1. This is a complexity analysis of this particular algorithm. Next, we will take one more algorithm called scheduling problem. So, scheduling problem is an optimization problem, where we have to schedule our resources effectively. This problem is a very popular problem in number of computer science domains. We encounter this problem in operating system as processor management. In many mechanical engineering applications, we encounter this problem as scheduling of machine jobs. We can encounter this problem in many circumstances like ticket counters in railway stations, etc., etc. So, the logic is very simple. You have limited resources. The question is how you will effectively allocate resources to the request. This is a thing. So, there are three types of scheduling problems. A scheduling problem without a deadline. So, that means without bothering about deadline, we can solve this problem with respect to profit. Our aim is to get maximum profit. Second type is scheduling problem where every task has got a deadline. Then third category is called scheduling for sub intervals, where we have the starting time as well as the finish time of the given task. Fine. First, we will consider the problem of scheduling without any deadline. Let us assume that we have 3 programs or jobs, which is having the service time or running time as 2, 7 and 4. So, you have only one processor. So, the question is how you will allocate these 3 jobs. So, you can see that there are 3 jobs. So, that means you have what you say 6 possible ways of scheduling. So, 3 jobs. So, that means scheduling is going to be like 1, 2, 3, 1, 3, 2, etc., etc. Imagine that I am following the policy of 1, 2, 3. So, what happens? The first job is having a running time of 2. So, it will be allotted to the machine. So, the second job has to wait. So, that means 2 is going to be the waiting time for the second job, and Once a waiting time is over, then it will be processed. So, it takes 7 units. So, meanwhile, the third job has to wait. So, 2 plus 7 is going to be the waiting time for the third job, and after that it takes 4 units of time. So, that means you can see that it is going to be 24. So, this 24 is arrived by taking into account of not only the running time, but also the waiting time. So, the turnaround time is nothing but the total time divided by the number of jobs. So, it is 24 by 3, it is going to be 8. So, similarly, you can also calculate the turnaround time for the other schedules. So, you can see that this is an optimization and we are looking for the optimal policy. So, the optimal policy is we have to schedule where the turnaround time is going to be very less. So, 7 is a minimum, therefore, we are coming to a conclusion that the best thing is going to be 1, 3, 2. So, that means it is 2, 4 and 7. This should tell something very important about this. That means, you can see that it is 2, 4 and 7 which is in the ascending order. In other words, you can see that the hidden policy of the shortest job first is being followed as part of this. In other words, imagine a scenario where I am going to a Xerox shop with another person, where my job takes only 3 minutes and his job takes 2 hours, then the logic is very simple. I should be allowed first because my job is having a lesser run time than his particular job. So, this sort of scheduling will guarantee the optimal solutions. So, the logic is very simple, shortest job first. So, the informal algorithm is very simple, sort all the jobs by the service time in the non decreasing order. Then we have the sorted list, where the sorted list is going to have the jobs that is sorted based on the running time. Then based on that I am going to allocate job from the sorted list. So, this is the informal algorithm. So, this is the formal algorithm. You can see that in formal algorithm, all we are trying to do is we are trying to ensure the implementation of informal algorithm. First sorting is carried out, then schedule is going to be null. Initially I am considering all the job, select the next job from the sorted list yes, and schedule that. So, keep on doing that for all the jobs. This is the formal algorithm without deadline. What is the complexity analysis? Complexity analysis is very simple. The first step is going to be sorting of all the jobs. So, that means sorting has to be carried out. So, it is going to be order of n log n, and scheduling for n jobs takes order of n. So, you can see that the maximum of these two is order of n log n, which is going to be the complexity analysis of this particular algorithm. Second algorithm is with a deadline. So, deadline means the time within which the job has to be computed, otherwise you will not get any profit. So, in other words, deadline is a time limit, before that the job has to be completed to get the profit. And we are considering a sequence. A sequence is feasible if all the jobs end by the deadline. So, now you can take this particular example. Now, you can see that there are 4 jobs, every job is associated with a profit and you have a deadline. For example, the first job has got a deadline of 2 units. So, that means the machine will take only 1 unit to fulfill all the jobs, but the deadline is 1. So, that means it can afford to wait for 1 unit as the waiting time, and it requires the machine assistance to get completed in another machine time. For example, I cannot allocate the sequence 2, 4 because jobs 2 and 4 has got 1 unit only. So, that means, if I allocate second job, so it will take 1 unit. So, by the time the deadline of the job 4 is elapsed, therefore, I will not get any profit at all. So, in other words, now this algorithm not only takes profit into account, but it has to take into account the deadline also. So, you can see that the feasible sequences are 2, 1, 3, 1, 1, 3, 2, 3, 4, 1, 4, 3. For example, 2, 4 is not feasible at all. Suppose if you consider these sequences, you can see that the profit you will have is on the right hand side. You can see that the profit is going to be 140, which is maximum for 4, 1. So, you can see that the fourth job is associated with the maximum profit, and you can see that now you can come to a conclusion that now we have to sort the jobs based on the profit as well as the deadline. So, this is a informal algorithm, sort all the jobs, then check the deadline as part of the feasibility. If that is the case, then you try to schedule that. So, if all the jobs are considered, then try to exit. This is the formal algorithm. So, you can see that there are n jobs given with service time. The aim is to generate an optimal schedule. So, first you are sorting. So, initially schedule is going to be null, then you are selecting the next job, then you are checking whether the deadline requirement are satisfied. So, if so, you try to schedule that, otherwise reject that. So, continue till all the jobs are considered. Finally, the solution set is returned. So, what is the complexity analysis? Again it is sorting. So, it takes order of n log n, then scheduling for n jobs takes order of n. So, the maximum is going to be n log n, which is going to be the complexity analysis of this particular algorithm. This is the third type of scheduling problem. So, here we are considering the sub interval. So, that means we are having a start time and finish time. So, compatible jobs are the tasks that can be performed together, and non-compatible jobs means tasks that can be performed together. So, the logic is very simple. Imagine a university. The university is offering lots of courses. Every course has got a start time and finish time. Suppose if there is a person called Jack wants to take 2 courses, means he can take only if there is no overlap of the courses. In other words, these courses should be mutually exclusive in terms of the start and finish time, then only these courses are feasible. I can also give you another example. Suppose if you consider reading as one activity, television watching is another activity, these two activities cannot go together. So, either I have to finish TV watching, then I have to study. This is what this algorithm is all about. You can see that for course selection, we are starting a loop, we are selecting a initial course, the next course we are taking and we are checking whether it is feasible to schedule, or otherwise we are going to reject that. This is a formal algorithm. So, you can see that we are considering the starting time and finishing time. If the starting time is greater than the finishing time of the previous task, then we are considering that particular course, otherwise that course is not possible. So, when we come out of this loop, we have a schedule that we can call as the optimal schedule. What is the complexity analysis? Again, this algorithm requires sorting, which is order of n log n. Scheduling takes order of n. So, the maximum is what is a order of n log n, which is going to be the complexity analysis of the task selector. In summary, we can come to a conclusion that greedy algorithms are very useful to solve optimization problems. While there is no guarantee that greedy approach always solves the optimization problem to give optimal solutions, there are many problems it is able to give optimal solution as well as near optimal solution. Therefore, it is better to study this design paradigm. Coin change is an interesting problem which can be solved using greedy approach. Scheduling problems too can be solved using greedy approach. So, thank you very much. Next module we will concentrate more problems that are coming under this particular category. Thank you very much.